Stray voltage problems can manifest in unexpected ways. While issues with the utility are frequently the first suspected cause of stray voltage, alternative sources can also be responsible. Consider the following scenarios where the origin of stray voltage was traced back to non-utility related causes. One case involved a homeowner experiencing electric shocks while in the shower. Initial investigations focused on the usual suspects, such as grounding and bonding issues within the home's electrical system. When these checks yielded no solutions, the electrical meter was pulled to isolate the home from the utility supply. Despite this isolation, the stray voltage persisted in the shower. Further investigation led to the discovery that disconnecting the incoming cable coax line eliminated the stray voltage issue. Subsequent voltage measurements revealed a significant potential difference of 90 volts between the cable shield and ground. This highlights that cable coax connections can, under certain circumstances, introduce stray voltage into a building's electrical system. Another instance involved a woman reporting electric shocks emanating from a kiddie pool in her backyard. Upon investigation, stray voltage readings were detected near the pool. By taking readings and observations near the property line, it was traced to a floodlight on a neighboring property. The floodlight was connected to the neighbor's house using an extension cord. The neighbor was forthcoming about the installation, revealing that they had spliced two pieces of cable together to reach the floodlight. After turning off the circuit supplying the floodlight and disconnecting the spliced cable, the stray voltage issue at the kiddie pool was resolved. These two examples clearly illustrate that stray voltage problems are not always attributable to the utility. Electricians and other professionals should be aware of these potential alternative sources when troubleshooting stray voltage issues. Here are some key takeaways to consider when investigating stray voltage problems. Firstly, broaden the scope of the investigation beyond the utility supply. Don't automatically assume that the problem originates from the utility company. Secondly, consider cable coax connections as a potential source. Measure the voltage between the cable shield and ground to check for any potential differences. Thirdly, examine neighboring properties for potential sources. Look for improperly installed wiring, extension cords, or other electrical equipment that could be contributing to the problem. Fourthly, pay attention to environmental factors. Damp or wet conditions can exacerbate stray voltage problems, making them more noticeable. Fifthly, use appropriate testing equipment. A high-impedance voltmeter is essential for accurately measuring stray voltage. Sixthly, follow proper safety procedures. Always wear appropriate personal protective equipment, such as rubber gloves and insulated boots, when working with electrical systems. Seventhly, consult with a qualified electrician. If you are not comfortable working with electrical systems, it is best to call a qualified electrician to investigate and resolve a problem. Eighthly, document your findings. Keep a detailed record of your investigations, including voltage measurements, wiring diagrams, and any other relevant information. Ninthly, communicate effectively with the customer. Explain your findings to the customer in a clear and concise manner. Tenthly, follow up with the customer after the problem has been resolved to ensure that the stray voltage has not returned. When dealing with stray voltage, it's important to remember several key concepts related to electrical safety and grounding, drawing from the National Electrical Code, or NEC 2008, and general electrical principles. Firstly, grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, while bonding ensures that all metal parts of an electrical system are at the same potential. Secondly, stray voltage can be caused by a variety of factors, including faulty wiring, damaged insulation, and improper grounding. Stray voltage can also be caused by induced currents from nearby power lines or electrical equipment. Thirdly, stray voltage can be dangerous, as it can cause electric shock. Even small amounts of stray voltage can be uncomfortable or even painful. Fourthly, the NEC provides specific requirements for grounding and bonding electrical systems. These requirements are designed to minimize the risk of electric shock and fire. Fifthly, it is important to use appropriate testing equipment to measure stray voltage. A high-impedance voltmeter is essential for accurately measuring stray voltage. Sixthly, it is important to follow proper safety procedures when working with electrical systems. Always wear appropriate personal protective equipment, such as rubber gloves and insulated boots, when working with electrical systems. Seventhly, it is important to consult with a qualified electrician if you are not comfortable working with electrical systems. A qualified electrician can help you identify and resolve stray voltage problems. Now let's discuss grounding and bonding in more detail. Grounding is the process of connecting an electrical system to the earth. This provides a low impedance path for fault current to return to the source, which helps to protect people from electric shock. Bonding is the process of connecting all metal parts of an electrical system together. This ensures that all metal parts are at the same potential, which also helps to protect people from electric shock. The NEC provides specific requirements for grounding and bonding electrical systems. These requirements are designed to minimize the risk of electric shock and fire. For example, the NEC requires that all metal water pipes that are used as grounding electrodes must be bonded to the electrical system. This helps to ensure that the water pipes are at the same potential as the electrical system, which reduces the risk of electric shock. The NEC also requires that all metal enclosures that contain electrical equipment must be bonded to the electrical system. This helps to ensure that the enclosures are at the same potential as the electrical system, which also reduces the risk of electric shock. In addition to grounding and bonding, there are other things that can be done to minimize the risk of stray voltage. For example, it is important to use high-quality wiring and electrical equipment. It is also important to inspect electrical systems regularly for damage. If you find any damage, it is important to repair it immediately. If you have stray voltage problems, it is important to consult with a qualified electrician. A qualified electrician can help you identify the source of the stray voltage and resolve the problem. In the case of the homeowner experiencing electric shocks in the shower, the stray voltage was caused by a faulty cable coax connection. The cable coax connection was not properly grounded, which allowed stray voltage to flow into the shower. In the case of the woman reporting electric shocks from the kiddie pool, the stray voltage was caused by an improperly installed extension cord. The extension cord was not properly grounded, which allowed stray voltage to flow into the pool. These examples illustrate that stray voltage can be caused by a variety of factors. It is important to be aware of these factors and take steps to minimize the risk of stray voltage. Here's some additional information about cable coax and its potential to introduce stray voltage. Firstly, cable coax is designed to carry radio frequency signals, but it can also conduct electricity. Secondly, if the cable coax is not properly grounded, it can become energized with stray voltage. Thirdly, stray voltage on cable coax can be caused by a variety of factors, including faulty wiring, damaged insulation, and induced currents from nearby power lines. Fourthly, stray voltage on cable coax can be dangerous as it can cause electric shock. Fifthly, it is important to ground cable coax properly to minimize the risk of stray voltage. Sixthly, the NEC provides specific requirements for grounding cable coax. Seventhly, it is important to use appropriate testing equipment to measure stray voltage on cable coax. Eighthly, it is important to follow proper safety procedures when working with cable coax. Ninthly, it is important to consult with a qualified electrician if you are not comfortable working with cable coax. Regarding extension cords, their improper use and condition can also be a source of stray voltage problems. Firstly, extension cords are designed to provide temporary power to electrical equipment. Secondly, extension cords should not be used as a permanent wiring solution. Thirdly, extension cords should be properly sized for the electrical load they are carrying. Fourthly, extension cords should be inspected regularly for damage. Fifthly, damaged extension cords should be replaced immediately. Sixthly, extension cords should be properly grounded. Seventhly, extension cords should not be run through doorways or windows, or under carpets or rugs. Eighthly, extension cords should not be overloaded. Ninthly, extension cords should not be used in wet or damp locations. Tenthly, it is important to follow all safety precautions when using extension cords. To further clarify grounding and bonding, let's delve into some specific NEC sections and requirements. NEC Article 250 covers grounding and bonding. It outlines the general requirements for grounding and bonding electrical systems. NEC Section 250.4 addresses general requirements for grounding and bonding. It emphasizes the importance of creating a low impedance path for fault current to return to the source. NEC Section 250.24 covers grounding of service-applied alternating current systems. It specifies the requirements for grounding the neutral conductor of a service-supplied alternating current system. NEC Section 250.50 covers grounding electrode system. It outlines the requirements for the grounding electrode system, which is the system of electrodes used to connect the electrical system to the earth. NEC Section 250.52 covers electrodes for grounding. It lists the types of electrodes that are permitted for use as grounding electrodes, such as metal water pipes, ground rods, and ground plates. NEC Section 250.64 covers grounding electrode conductor installation. It specifies the requirements for the installation of the grounding electrode conductor, which is the conductor used to connect the electrical system to the grounding electrode. NEC Section 250.92 covers bonding of metal enclosures. It outlines the requirements for bonding metal enclosures that contain electrical equipment. NEC Section 250.94 covers bonding of other metal parts. It specifies the requirements for bonding other metal parts of an electrical system, such as metal water pipes and metal gas pipes. In addition to these specific NEC sections, there are many other requirements for grounding and bonding electrical systems. It is important to consult the NEC for complete information on grounding and bonding requirements. Now let's talk about electrical safety in general. Electrical safety is the practice of working with electricity in a safe manner. It is important to follow electrical safety procedures to prevent electric shock, fire, and other hazards. Some basic electrical safety tips include: firstly, always turn off the power before working on electrical equipment. Secondly, use appropriate personal protective equipment, such as rubber gloves and insulated boots. Thirdly, inspect electrical equipment regularly for damage. Fourthly, repair any damaged electrical equipment immediately. Fifthly, never overload electrical circuits. Sixthly, never use extension cords as a permanent wiring solution. Seventhly, never run extension cords through doorways or windows, or under carpets or rugs. Eighthly, never use electrical equipment in wet or damp locations. Ninthly, always follow the manufacturer's instructions for electrical equipment. Tenthly, consult with a qualified electrician if you are not comfortable working with electrical systems. Stray voltage can be a complex issue, and it is important to approach it with a systematic and thorough approach. By considering all potential sources, following proper testing procedures, and consulting with qualified professionals, you can effectively identify and resolve stray voltage problems. Remember to always prioritize safety when working with electricity, and never hesitate to seek help when needed. Also, be mindful of environmental conditions. Moisture greatly enhances the conductivity of electricity, making stray voltage problems more pronounced in damp environments. Standing water, wet soil, and even high humidity can increase the risk of electric shock from stray voltage. Therefore, pay close attention to weather conditions and take extra precautions when working in wet environments. Use ground fault circuit interrupters, or GFCIs, in areas where water is present. GFCIs are designed to detect even small amounts of leakage current and quickly interrupt the circuit, preventing an electric shock. Ensure that all outdoor electrical outlets and equipment are protected by GFCIs. Periodically test GFCIs to verify that they are functioning properly. If you are unsure about the safety of an electrical situation, it is always best to err on the side of caution and consult with a qualified electrician. Finally, remember that electrical codes and regulations are constantly evolving to address new safety concerns and technological advancements. Stay up to date with the latest codes and regulations to ensure that your electrical work is safe and compliant. Continuously educate yourself on electrical safety practices and procedures. Attend training courses, read industry publications, and participate in professional development activities to enhance your knowledge and skills. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. By working together and promoting a culture of safety, we can create a safer environment for ourselves, our families, and our communities.